Lesson 1C, Polar and Nonpolar Molecules. Nonpolar compounds are molecular compounds in which the lone valence electrons not involved in bonding are evenly and linearly distributed across the molecule. For example, CH4 methane. Neither the carbon nor the hydrogens have non-bonding valence electrons, which means there are no electrons to worry about. They're all in the bonds. It is not polar. The same can be said about diatomic hydrogen. Its valence electrons are in the bond, and there are no other electrons, so it is nonpolar as well. O2 does have non-bonding electrons other than the bonding electrons in the middle. These non-bonding electrons are 4 on one end and 4 on the other end. The molecule is straight. The sharing of the non-bonding electrons is even and in a straight line. It is also nonpolar. Polar molecules occur when the free valence electron in a molecule is not evenly shared or distributed, and or the molecule has a bent shape. Water is a great example of this. The oxygen atom has free valence shell electrons, while hydrogen doesn't. These electrons tend to hang out at the top, making it more negative than the bottom. This hanging out of the two pairs of non-bonding electrons at the top also bends the molecule, so as a 104.5 degree bend between the two hydrogens. This uneven distribution of negative charges and the bending of the molecule indicates that it is polar. In fact, it is bipolar. It has a more negative oxygen end, denoted with the sigma minus sign, and the more positive hydrogen ends, as denoted by the two sigma plus symbols. When we look at the molecule as a whole, it's neutral. However, due to the uneven distribution of electrons around the molecule, combined with its bent shape, it has a slightly positive end and a slightly negative end. These slightly charged ends of water molecules make them stick together to one another like magnets. We call these H-bonds. Negative to positive and positive to negative. This is a very important quality of water, which we will talk about again in the future. Let's look at hydrogen fluoride. Is it polar? Well, the formula for it is HF. Its Lewis diagram looks like this, and its ball and stick model looks like this. So is it polar? From these illustrations, it may not seem so. It's straight. And where are the non-bonding valence electrons? Well, here they are, and as you can see, fluorine has 7 valence shell electrons, 1 in the bond, leaving 6 free valence shell electrons, while hydrogen has no free valence shell electrons. Even though this molecule is straight and neutral in overall charge, it definitely has 2 poles, the slightly more negative fluorine end and the slightly more positive hydrogen end. Hydrogen fluoride is polar.